we're going to take a look at factoring two terms that are differences of squares. And we're going to start with this example. I've got 4x squared minus 9. Notice how everything is squared. For difference of squares, we get to use this formula. So a squared minus b squared is equal to this factorization, a plus b times a minus b. All we have to figure out are the values of a and b. Okay, so back to our example. In our example, I've got this 4x squared, that's my first term. So I have to decide what was squared. This is going to be my a value. So what was squared? That's going to be a 2 squared for the 4, and then an x squared. So it was a 2x that was squared. So a is equal to 2x. Let's go and do the same thing with that 9. Okay, so with that 9, the 9 is definitely a 3 squared, and b then, that second value being squared, is equal to 3. Okay, so let's put this into our formula. So our formula for factorization is a plus b, so their sum, times their difference, a minus b. Putting our values together, that is going to give us, the sum is going to be 2x plus 3, so 2x plus 3, and then their difference is going to be 2x minus 3, and that's our answer. Now I've got 3 more really important examples, so you're prepared for all of your homework. Let's go ahead and do the next one. Now again, we're looking for values squared, and the x is squared, but the 12 and the 3 are not something squared. However, the very first step that you want to do when you're factoring anything is to look for a greatest common factor, a factor that all of your terms share. And in this case, I do have a greatest common factor. Let me write it over here. My GCF is a 3 because 3 goes both into 12 and into 3. So my GCF is equal to a 3. Let's go ahead, before we do the difference of squares, let's divide and factor that 3 out in front. So I'm going to record that 3 out in front. Okay, so what are we left with? 12 divided by 3 is equal to 4. I still have that x squared. That's great because 4 is something squared. And then the 3, anything divided by itself is 1, and I've got that negative sign out in front. Okay, perfect, because now we've got squared values. So I see that this 4x squared is actually a 2x quantity squared, so that's going to be my a. A is equal to a 2x. And my 1 is just 1 squared, so b is equal to 1. So putting these into my formula, a plus b, a minus b, and I'm also not going to forget that I've got a GCF out here in front. I almost forgot it. My GCF is that 3. Okay, so 3 goes out in front. And then a plus b, so I need 2x plus 1, so 2x plus 1 times their difference, 2x minus 1. Remember I said I've got some really important examples for you. This is one that can be tricky, but I'm going to break it down so that it's not tricky at all. I'm actually going to look at each of the values, each of the numbers and variables separately, even though I've got a fraction. So I noticed that this 25 is a 5 squared. The x, of course, is an x squared. This 4 is a 2 squared. I'll put that little squared there. And my 9 is a 3 squared. So as I look at everything separately, especially my numerator and my denominator, I can come up with my values. So 25x squared is the quantity 5x squared. This is going to be my a. So a is equal to 5x. And then that 4/9, I'm going to write that as a fraction. And then I look at the 4 completely separate. What squared is 4? That's going to be a 2. What squared is 9? That's going to be a 3. So my b value is equal to a 2/3. Okay, yay. Now for the easy part. I just want to factor this into their sum times their difference. There is no GCF, so just their sum times their difference. I've got a as a 5x, so it's going to be a 5x plus 2/3, and then 5x minus 2/3. Okay, here comes that last one, maybe the most important one of all the examples that we've seen. In this last one, I do see some things that are squared, the a and the b, but the 2 and the 50 are not, so I'm thinking GCF. I've got two terms here, so I'm really thinking a GCF. And I do notice that the 2 and the 50 are both divisible by 2, so I do have a greatest common factor there of 2. Let's go ahead and divide that 2 out. So I divide the 2 out and I record it out in front. What are we left with? That 2 cancels and I get the a squared. Perfect. So I've got a squared first term. And then 50 divided by 2 is 25. So I've got plus 25b squared. Everything looks good except for one really critical symbol here, and that is our plus sign. This one is not factorable any further. You cannot factor a sum of squares, which means that what we've got right here is our complete factorization. You are doing great with factoring. I've got another video for you here.